DeMoivres theorem then. Here it is written out. Not something we tend to remember. It'll always be given, or you can look it up. But actually it's not difficult to work out. It only works in polar form. So if I'm trying to use DeMoivres theorem, then I need to make sure my complex number's in polar form. It's a way of raising a complex number to a power n. So I could be squaring it, I could be cubing it. Remember that the square root of a number, when we touched on this when we did our algebra, the square root of a number, say x, is equal to x to the half. So in other words, I can convert something like the square root to a power. The cube root of x squared, using one of the laws of indices, turns out to be x to the 2/3. So I can convert something like a square root or a cube root into a power, and then I can apply DeMoivres theorem. N would be 2/3 in that particular example. So whenever I'm raising a complex number to a power, I use DeMoivres theorem. Same for laws of indices. X to the -2, if you remember, is 1 over x squared. So again, if I've got an inverse, 1 over x squared, I could call that x to the -2. And again, I can apply DeMoivres theorem, and n would be -2. So that's DeMoivres theorem, and what's it saying? If we look at it, it's quite straightforward, really. Here's my complex number in polar form. It's saying I take the magnitude of that complex number, r, the modulus, and raise it to the power of n. So if I'm squaring, I just take my magnitude, whatever that is, and square it on the calculator. And the angle part, the argument, is just whatever the angle is times the power. So times 2 if I'm squaring. So you multiply the angle by the power and raise the modulus by the power. That's effectively what DeMoivres theorem is telling us. For example, 4 angle 25 degrees cubed equals. What we do in this case is we apply DeMoivres theorem. That's, we raise the modulus to the power 3, so 4 cubed, and the angle would be 3 times 25 degrees. 4 4s are 16, 4 16s are 72. Is that right? 4 16s? Yeah, 64. Thank you, saved me there. Angle 75 degrees. Applied. Done. If it's in rectangular form, square root of 3 plus 2j, the first thing I need to do is change it to polar form using the calculator, and then apply DeMoivres, remembering that the square root is to the power of half. So there's an example of applying DeMoivres theorem to square root a complex number. So the only problem we have with DeMoivres theorem that we might forget is that we have multiple angles possible with roots. For example, the one we've just looked at, the cube root of 4 angle 36, well maybe we didn't, but there it is. So apply DeMoivres theorem, the cube root is to the power of 1/3. So that's 4, the cube root of 4, or 4 to the power of 1/3, and then 1/3 of 36 will give me the angle. So we end up with this, 1.587 angle 12. And for DeMoivres theorem, the rule is that if we've got cubing, we've got 3 angles, to the power squaring, we've got 2 angles, and so on. The cube root, we've got 3 angles. So as many angles as there are in the root. And so if I've got to work out what the other angles are, I've worked out the first angle, 12 degrees. So to get the other angles, I take a complete turn, 360 degrees, or if I was working in radians, 2 pi radians, and divide that by 3, 120 degrees, and then add this to 12 degrees once to get the first angle, and then again to get the second angle. So for example, in this particular case, if I had 120, I'd get 132 degrees, and if I had 120 again, I'd get 252 degrees. So in other words, there are 3 possible solutions if I find the cube root of a complex number. So here it is stated, for roots we have the fact that there are as many solutions as the value of the root, so that's the way to remember it. So if I'm after the 5th root, then there's 5 solutions. So first solution is at 50 degrees, and then to get the other ones, I would take my 360 degrees and divide by 5, which would give me 72, and then I just keep adding 72, and then I'll get back round to 50 degrees again if I've done it correctly to get my other angles. Here's one to have a go at, okay? And I'll pause this video and let you have a go at it, and then put the solution down so you can check you've got it right. So let's just have a go at one. Find the cube root of 3 plus 2j squared. So there's the solution if you want it. 3 possible roots. 1, 2, 3. Have a look at the working.